The Mesoamerican Barrier Reef System is the world's most diverse marine ecosystem that stretches along Mexico, Belize, Guatemala, and Honduras. Their reefs are very important to supply their ecosystem services, which among others include fisheries, tourism, shoreline protection, and biodiversity. Coastal community livelihood and food security is dependent on reef-related activities, directed or indirectly. Coral reefs play a key economic role and are also a central part of the cultural life and identity of people living in coastal areas. Human activity and environmental stress remain a threat to reef resilience. The need for coordination management plans and conservation actions at the regional level to enhance the sustainability of reef resources and people's livelihoods is stressed. Several critical threats were identified as having caused the degradation of corals throughout the region. The highest effects on coral mortality and bleaching were found from thermal stress caused by rising ocean temperatures. Excessive fishing practices have also reduced the abundance of herbivorous fish that help regulate algae growth in the reef. Additionally, sedimentation, nutrient runoff, and pollution will increase as the coast develops, which will continue to diminish the resilience and recovery potential of the reefs. The stressors have increased over time and are projected to increase under future climate change scenarios. The effect of local pressures and global warming illustrates the multifaceted nature of the environmental and human-related causes of the coral decline. Relationships between thermal stress, coral morphology, susceptibility, and coral mortality were analyzed. Degree weeks, or DHW, had the greatest impact on coral mortality levels. The number of mortalities increased significantly with high thermal stress, notably at DHW 50, but stayed relatively low at moderate stress. Results were also dependent on the timing of the observations, with mortality gradually accumulating after bleaching events. The coral morphology also influenced vulnerability, the branching and tubular having the greatest vulnerability amongst the massive and encrusted corals. These results show that the degradation of corals is a combined effect of biological and environmental stress factors and not one solely. The management response on the Mesoamerican Barrier Reef region has consisted of conservation actions such as creation of marine protection areas, temporary restrictions on fishing, monitoring and control strategies. In certain protected reefs, the implementation of no-take areas and fisheries regulations have enhanced ecological characteristics through the protection of herbivorous fish and the reduction of direct pressure from humans. Those effects, however, are also revealed by the findings that local management is not enough to mitigate the impacts of the global climate change and ocean warming. Long-term monitoring, coral restoration, citizen science, and climate change measures should thus be chosen as priorities in this future. An integrated management response, which integrates local conservation and global climate action, is still needed to sustain reef ecosystems.